Ignoring air resistance, the horizontal component of a projectile's velocity, A, is 0, B remains constant, C continually increases, or D continually decreases. So if we're at the edge of, say, a cliff, and there's ground level beneath us, and if you throw a ball horizontally with a certain velocity of, say, 5 meters per second, we want to know, as it follows its parabolic motion, of whether or not it will increase its speed, decrease its speed, remain the same, or be 0. So if there is no air resistance, choice A says our velocity is 0. But if we've thrown it with a velocity of 5 meters per second horizontally, which would give us a projectile motion, it has to have some horizontal velocity which we gave it. So right off the bat, A is 0 is wrong. That's not true. It has to have some velocity. Otherwise, you would be saying you're just dropping an object and it's falling straight down to the ground. That is not a projectile motion. Projectile motion requires a vertical and horizontal components, which would result in a parabolic motion as you fall. So you have an x velocity and a y component of velocity. B states it remains constant. Well, in this direction, if we've just thrown a ball, there is nothing to accelerate it in any direction, so as it's falling, its velocity remains constant, while the vertical, the y component, will increase as it's falling and decrease on its trip up. So if you threw an object up, its velocity would decrease as it goes to the top. The y component would be 0 at the top. There would still be an x component, and then as it falls back down, the x component remains the same while the y component increases. So B remains constant is true. C says it continually increases, but as we stated before, there is no force, no means of acceleration for this ball as it is traveling along this projectile motion in the x direction. There is the acceleration due to gravity, but that is only affecting the y component of its velocity. So C doesn't do anything, and D, it continually decreases. Once again, there is no acceleration acting upon it in the x direction, so that is also not true. So once again, B, our velocity in the x direction, its horizontal component, remains constant throughout the entire trip because it's not acted upon by any outside forces or any means of acceleration as it is following the path, or otherwise known as the trajectory. So once again, the answer is B. The x or horizontal component remains constant.